Greetings. I would like to welcome all my dear children and my students to this video session. In this video session, I would like to focus the Unit 5 of the subject Multi-Core Architectures and Programming Regulation 2030, that is CS6801. As we know already, I have launched the MCQ videos for first 4 units. And this video we are going to conclude. I hope all my students and children watched those videos and benefited. Very good feedback and more views. So I am so happy. I would like to help you a lot. But only the prime objective is that all my children wanted to get score highest grade. That is our objective. So with this word, I would like to start this one. So it's a 5th unit. So as far as the 5th unit is concerned, this is the syllabus. So actually 5th unit focuses parallel program development. So it's a case studies, n-body solvers, tree search, OpenMP and MPI implementations and comparisons. As far as this unit is concerned, more implementation side and simulation side. So I didn't focus much reason because more demonstration is required and on each topic we wanted to speak much. That is the reason why I didn't focus everything, only a few keywords, and my dear children, please understand those keywords and the calculation methodologies so that will help you to comfortably complete MCQ questions in the 5th unit. So that is a n-body solver. That means it is a solution. Before this, we wanted to identify n-body problems. So we have that is a more problems. Those problems wanted to solve in parallel. For this purpose, we have n-body solvers. So very important concept. Before what is called focusing concepts, technologies, I would like to run two simulated output so that you can understand the power of OpenMP. I already told you OpenMP is a fantastic tool, API tool, you know very well. It is proposed for parallel execution. So to achieve that one, so we have certain what is called simulated output video I would like to run so that you can enjoy and you can understand the power of OpenMP. So we have that small tasks and all small parallel programming tasks that can be implemented easily. For example, if we have n-body problems, the n-body problem is nothing but that is hundreds of what is called particles. Imagine that moving, and we wanted to monitor those particles, what is called the location, the particles velocity, particles acceleration, and like this the total force and everything we wanted to monitor, and we wanted to predict its a new location, that means a new position and a new acceleration value, new velocity value, new what is called the force, because during motion, okay, the force will continuously may change, acceleration may change, position will change, velocity may change, like this. Okay, all these parameters we wanted to collect and we wanted to predict the position also. So actually real concept, real model, it will execute. In our simulation we wanted to execute like reality. Okay, it is in the simulation. So for this purpose, okay, in this unit we focus n-body solvers. More input I wanted to give you. Let us consider a input. Okay, so for example, one particle is moving. So we wanted to measure, that is particle mass, particle new position and particle velocity. Based on this, we can calculate the force. You know these things and all. What is mass, what is position, what is velocity, and what is force, and like this. So to understand the particles moving new position and new what is called force, measuring a new force is a very important one. So that's the reason why we are focusing what is called the n-body solver over here. Before demonstrating our what is called the theoretical concepts, I would like to run a small what is called a simulator. So from the simulators we can understand how this OpenMP supporting under the concept of n-body solver to predict what is called the particles new location and new velocity and a new force like this. I would like to run that is first simulator. Please watch. Parallelly, I would like to give you explanation also. Let us consider this video is running. So as far as this video is concerned, clear. So that is these are the different particles. All the particles and are moving. So I wanted to understand. For example, now time is also started at a particular moment. Where is this location of this particle and what is its velocity? What is its acceleration? And what is its force? This particle is attracted by another particle. At the same time, neighbor particle is attracted, and like this, lot of things we wanted to understand. So for this purpose, we needed a very good mathematical model, and not only that, this execution should be performed, should be simulated with the powerful parallel computing architecture. For this purpose, we have what is called OpenMP. So imagine that it is a small numbers given, but later on I will show you numerous numbers like this. 5 millions of particles may move parallelly. So we wanted to understand, we wanted to analyze, and we wanted to predict, and we needed to record all those 5 million particles, what is called velocity, force, new positions at a particular time. For example, I can ask you at a particular time, what is the location of the particular particle. For example, consider this particle. This particle I executed, that is a few seconds. Let us consider 5 seconds. During a second, understand, or you understand third second, what is the position of this particle? What is the acceleration of the particle? What is the force of the particle? And how much force exerted by other particles on this particle, like this we wanted to analyze. So it is a parallel task. I am referring this one particular particle, like this tens of thousands of particles and all there. All those particles positions, velocity, and what is called resultant force we wanted to measure. So that is a main objective of this model, of this OpenMP model. So we can understand it here. So now I would like to run. It is going. So this is one of the outputs you can understand. So to observe all these particles measurement, we wanted mechanism. How to measure? So imagine that this is the idea. That is a space. X-axis and Y-axis. And after that, let us consider. So we have a particles here. This is for 3 dimension also. If needed, you can use that. And after that, let us consider. So we have a particle here, particle here, particle here. And here you important one information I would like to give you. For example, this particle, and this particle may attract this particle. At the same time, this particle may attract this particle because you know the concept of gravitational force. Because the entire galaxy, I would like to demonstrate with the simulation, entire galaxy is perfectly functioning at the center sun. Then after that, what is called numerous, what is called the planets and all, you know very well, with its own orbit, without any deviation, it is revolving and rotating the sun. You know very well. How it is possible? Because of attraction. So gravitational attraction towards the sun as well as repulsion. So attraction force as well as repulsion force and all equal, so that without any disturbance, it is revolving itself and it is rotating the sun. So that actually happening, that I wanted to simulate with the parallel model. For this purpose, we are using what is called the Open MPI. Okay, so that is a very important concept and excellent facility of this Open MPI, so that we are achieving. Okay, let us see this diagram so you can understand. Okay, so attracting and also I already demonstrated. Let it run. Okay, here, so that is, what is this? It is a time displacement, you know very well, differential equation and the integrations concept also. Okay, with that equations, we can identify with a small difference of time what is the particle's new position and new velocity, new acceleration and new resultant force. Let us consider x-axis and y-axis. Okay, so that is one of the axis. Let us consider, okay, that is x is the time and y is what is called one of the coordinator. Then after that, during a movement, okay, the particles locations velocity can be measured. So for this purpose, we can use what is called this differential equation called delta x by delta y. You know very well. Okay, this is a small concept. In our schools, we have studied these ideas and that. Okay, so with this, I would like to demonstrate that is another one. See here. Okay, so different particles moving, okay, and continuously moving. For example, it started just over 1 second before. Okay, I wanted to understand at a particular time. Imagine that this location, for understanding purpose, I tell you that the information should be measured. For example, this particle, when at this time, okay, what is its velocity and how much force, okay, exerted by itself and other what is called particles. So see this simulation, then you can understand it is happening. Okay, it is simulated. During simulation, entire data wanted to record by our parallel computing architecture and should be stored, and this can be analyzed for future predictions and all. See now here how many what is called more number of particles moving, and all those particles velocity, position, force, everything should be recorded. So it's a parallel computation is going on. So it is not an ordinary task. With the ordinary processor, it is impossible to manage and maintain. So because of that, we are using what is called OpenMP. Okay, so that is a strength of this architecture. Similarly, see here, okay, that is a parallel architecture going on. Then you can understand, okay, how it is going. So like this, we can take what is called real-time examples also. So with that real-time examples, we can analyze. Let us consider what is called galaxy. So imagine that this is the galaxy. So that is the sun. Then after that, planets and all there. So that is each planet is what is called rotating, okay, revolving, rotating the sun. You know very well. Okay, it is moving like this. So entire planet's, okay, movement, all the times it is continuously parallelly doing. For example, this is rotating and moving. At the same time, this is also moving. This is also moving. So our parallel system wanted to measure it, this planet, what is called new position, velocity, acceleration, force. Similarly, this one like this. Everything should be monitored continuously, so that if I am asking my system at a particular time, what is the velocity and the location of this particular planet, so I wanted to get. So for this purpose, okay, we are using what is called n-body problem. So n-body problem is a issue. Issue means, okay, all these planets are moving, rotating a sun. Okay, so I wanted to identify these planets, the new position, new velocity, new force, and like this I wanted to measure at a particular time. Imagine that, okay, 10 hours it was executed. Okay, in this third second, what is its velocity, what's its position, okay, fifth second, what's its position. After that, even I can predict also. For example, it is executed 1 hour, then after 1 hour, 66th minute, what will happen, where is a new position, what is the most probable velocity, and like this we can predict under. So imagine that it is a galaxy. Okay, you know very well, galaxy is a collection of, huge collection of gas, dust and billions of stars. All stars and all moving. Okay, I wanted to record okay, each star's locations, velocity and everything. So for this purpose, we can use what is called this OpenMP mechanism. Okay, so I would like to run so that you can understand. So the parallel task is already started. See here. Okay, see here. Okay, the parallel tasking. Okay, for understanding purpose, splitted like this. Okay, sun, in the sun, okay, one of the planets is moving. It is recording. Parallel processing is happening here. This sun, okay, another what is called the planet is moving. Parallel processing. So this is a recording. Okay, this activity is also recording. Third activity also recording, and like this, like this, like this. So please understand the calculation and prediction of what is called the new position, new velocity and force and all. Okay, it's not a simple issue. The mathematical model wanted to execute. So the parallel computing architecture in each second, in each millisecond is calculating entire details and it is recording. So this is the strength of OpenMP. Okay, so with this, I hope okay you understood the theory. Okay, so now you understood that okay how that is numerous particles and all moving, and those particles force wanted to understand and calculate, and total force also needed to total force I am referring. Okay, that is a one particle nearby, that is a 3 or 4 particles. Because of those particles, okay, more attractive power is will generate. Okay, that force we wanted to measure, and the acceleration and the distance between what is called two particles, and like this. Okay, different calculations are required. Everything is possible with the help of OpenMP under the concept of n-body solvers. So all these particles moving now. So that what is called the task is considered as n-body problems. So n-body problem is nothing but thousands of particles. Let us consider moving. Okay, we wanted to understand, we wanted to calculate those moving particles, velocity, position and forces and all. Oh, this is a problem because we wanted to calculate. To achieve these things, we have what is called the n-body solver. It is helping us. This n-body solver was implemented with the help of OpenMP. Okay, so that is. And one more simulation also I'd like to run so that you can understand the strength of OpenMP. See here, this is the example of gravitational force. These all are what is called particles. Okay, that is 5 million particles are here. All 5 million particles are going to perform. Okay, everything is recorded by parallel computing, and okay, it is animated now. See the animations. It is not an ordinary task. Because of OpenMP, we are achieving like this. Imagine that no OpenMP, it is impossible to simulate like this. And not only that, the gravitational force here, okay, that is more particles, so that all other particles and all attracted towards its particles like a sun. Okay, the sun, okay, is attracting all other planets, so that without deviations, properly the galaxy system is functioning. Okay, so that you know very well. So this is one of the examples, and like this we can understand all our everything particles. Okay, the simulated with OpenMP. So you can understand. See here now. Okay, here that is a more particle. So because of gravitational force, all other particles are attracted towards its what is called location. Because here more particles, so that more particle means more force, so that it is attracting. Okay, so with these words, I would like to stop these theoretical ideas and demonstration, and the theoretical ideas we will focus. Okay, so from this simulated output and watched video, from this video, I hope you understood that okay, more number of particles and are moving and attracting each other, and because of gravitational force, okay, force is generating, acceleration is happening, velocity wanted to measure, a lot of what is called demands. Everything is measured by okay, the system with the help of OpenMP. So that's a very important one. Because of OpenMP strength, okay, the n-body solver was introduced. Let us consider no OpenMP. So n-body solver okay, cannot be designed. We wanted supercomputer. So with a single i7 or i8 processors, okay, we can demonstrate n-body solvers because we have a OpenMP. It is a strength. So we will discuss one by one. Okay, so see, you know very well what is a force. Okay, the force is the gravity. Okay, you know very well what is the force and all, isn't it? So because of what is called that particle, what is called the force, energy will be generated. That energy will attract the another planet or another particle also. You know force. And total force means more force. I show the diagram so that we can understand. See here, okay, here this is the one particle and this is another particle. This is another particle. Imagine this is a particle. Okay, so here is a particle. So this particle has energy. This particle attracts neighbor particle. Okay, one force towards like this. Similarly, here there's a particle. It attracts this particle. So energy is here. Because of the equal energy, okay, both the particles in the same location. Gravitational force, you know very well. Please imagine, okay, that is solar system or that is a galaxy. Okay, and at the same time, as far as this particle is concerned, more particles surround this so that this particle exerts more energy. So it consumes more energy. Because of that more energy, okay, it attracts all entire particles. So please understand. So this is called total force. Okay, one force because of this particle, second force because of this particle, and like this going on. For demonstration purpose, we considered only two particles because one particle this and another particle, how that is energy is attraction is happening or that is resultant force is creating. Okay, we wanted to understand. So already you know very well, you studied in our school, okay, Newton's laws and all. Especially this attractive force is, okay, focusing Newton's second law. So I am not demonstrating that one because you know very well, okay, with the help of Newton's second law, okay, we can calculate the position of a particle and the velocity of the particle. So let us consider this is a formula. So this formula, okay, is used to calculate force of a particle. Let us consider particle. Okay, the particle is Q and that is exerted by particle K. Let us consider this is a particle Q and this is a particle K, and okay, this is, okay, attracting each other. How to calculate this force? Okay, that is a force. Okay, that is a Q, K. Okay, at a particular time I wanted to measure. For example, I run that is a 1 hour. With the 1 hour different slice, I wanted to store these records. Okay, so G refers, what is this? Gravitational force. Okay, MQ refers Q particle mass, K particle mass. Okay, and okay, that is a SQ. SQ is the location. For understanding purpose, see this diagram, you can see, okay, that is a location. For example, this position, okay, the particles at this location and this location with the coordination, okay, coordinated value, okay, x-axis, y-axis value, so that one particle's positions I can be fixed. Okay, so please understand, you already studied this, so that I no need to explain much. So with this help, okay, I can find out the position of Q particle and the position of what is called the K particle, so that I can calculate what is called the distance. And the distance cube is required. It is a formula to calculate a force. Okay, so denominator, what is called the distance cube, that is R cube. Okay, you know that is you already studied in your lower class, so you know very well. Okay, so because of these calculations, okay, we calculated, and this one, okay, it is a formula. Okay, so SQ refers what is called the Q position, K position. Okay, with this formula we can calculate what is called the force of QK. Okay, with respect to Q, K exerted, or with respect to K, Q exerted. Okay, that's all. So this is the force. Let us consider more particles are like this. So I explained only this one. Let us consider this is Q and this is K. And consider this diagram. Okay, this is a single one, center, and after that surrounding more packets, more particles. At that time, what is the total force? So total force can calculate like this. Same formula, no difference and all. Same formula, only thing is, okay, that is more number of particles, okay, so that n equal to 0 to n minus 1. It is a summation. Okay, that is, you know very well, it is a summation. Same formula we used, isn't it? Only that is from first particle to n particle. That means 0 to n minus 1 or first to n. Both are the same. You comfortably, you can understand this formula. You can enjoy this formula. So with this formula, we can calculate what is called total force or resultant force of this particle exerted by this particle by all this particle. Okay, this is the idea. So in this university examination, okay, we may expect the question, what is the formula for calculating a force? What is the formula for calculating what is called total force? What is the formula for calculating distance between two particles? Because a distance, this is a formula for calculating distance, and also I will demonstrate. So like this we can expect. Okay, then after that acceleration, because the acceleration you know very well. Okay, that is acceleration q equal to at the timing. See here acceleration, because of that double derivatives here, because acceleration you know very well, physics you studied most probably. So this is the equation for calculating acceleration of the particle q at a particular time t. Let us consider g is the gravitational force and m is the mass of that particle. So like this. Okay, you know very well. So accelerating. So this formula also please remember, most probably we can expect. And this is the methodology for calculating distance between two particles. So this is the methodology for identifying the location of this, okay, location of the particle. For example, one particle here, and okay, that is the second particle. What is the distance? So x-axis and y-axis. Okay, as far as this diagram is concerned, this is x1 and this is x2. This is a y1 and this is a y2. That means x1, y1, x2, y2. So that is x2 minus x1. So that is 7 minus 3. Okay, and then y2 minus y1. That means 8 minus 2. Okay, so like this, that means 7 minus 3, what is called 4. Okay, here what is called 4 squared, 16, plus, okay, 8 minus 6, 2, that is 6. So that is 36. Like this, okay, we will calculate and you can get what is called a distance and all. So this is the method, formula for calculating a distance between the two particles, because d is the deciding factor, okay, to calculate the force under. Okay, you know very well. Okay, then force equal to mass into acceleration. Okay, you know that is already I demonstrated what is the formula for calculating a mass and what is the formula for calculating a force, so that if with this formula we can calculate what we wanted. For example, if we know mass and acceleration, we can calculate the force. Or if I know that is a force and what is called a mass, I can calculate acceleration. That means F by m. You know that is algebraic concept. It is very simple concept. Okay. So this and all we can expect in this university examination. I already told you. Okay, that is a force equal to gravitational force into the masses of what is called two particles divided by distance cube into distance. See, same formula we used here. Okay, see here, same formula we used here. Okay, so that is a mass, then after that the distance between two, and okay, there's a distance, same formula. Okay, so we can understand this is the method, mathematical model for calculating a force under. With this idea, now we are focusing OpenMP code. Okay, this is the OpenMP code. Okay, so already I demonstrated what is mathematical model. The same mathematical model we are developing a code. Here, this is a very important 2. Okay, K is a one particle and Q is a particle. If both are not equal, then you will execute. If it is equal means it seems to be a single particle. Okay, so that is a x difference, x position we can calculate, y position we can calculate. From that distance we can calculate. Already explained the formula and all. Then distance cube also we are calculating. Purpose is I wanted to substitute here. For this purpose, okay, cube also calculated. Then force also calculated. Okay, so that is from this formula. Okay, we calculated okay, distance and force. This is one idea. Okay, this is called as that methodology is called as reduction algorithm. So why it is called a reduction algorithm? So for example, two particles, the particles force and all, okay, maintaining in this what is called two-dimensional array. Okay, so this what is called, this means, okay, the first column, second column, third column, column wise force Q value I am recording, and what is called row 1, 2, 3, row wise the force, that means particle K force I am recording. Okay, so this diagonal is always 0, reason because both are equal. Okay, now, okay, see here, this is the positive force and this is the negative force. So why I am telling like this, it is very simple concept. As far as this force is concerned, okay, this is attracting, or as far as this particle is concerned, it is repelling. But the force is the same. Let us consider 10. Okay, this side attracting means plus 10. Here repulsion means minus 10. So the quantity is the same. Only what is called attraction or repulsion, isn't it? So see here what is called minimizing each other repulsion, so that the minus sign also came. Okay, you know that is mathematical model already studied in physics, so I no need to explain much. Okay, so because of this, okay, this what is called a two-dimensional array is a diagonal. This is a positive and this is a negative. So upper side is called, you know very well, upper matrix diagonal, okay, triangle, upper triangle. This is lower triangle. You can choose either this upper or lower. Most probably we can choose positive. That is the reason why it is called a reduction algorithm. 50% of the information no need to focus to calculate force. That's the reason why it is called reduction algorithm. So in this reduction algorithm, we calculate distance and we calculated force. With this idea, we are moving to, that is another mechanism called Euler method. So Euler method is the supporting mechanism which will help what is called reduction algorithm to calculate position and the velocity. Okay, so already, okay, this is what is called Euler's method. Okay, this delta, okay, small change, you know very well, that is x-axis timing and y-axis, okay, dy by dx equal to y, you know already studied. Okay, this is the equation exponential x. So the same pattern. That means, okay, here I can calculate one slope, here I can calculate another slope. Based on that, I am what is called extending y. So that is exponential. So Euler's method, the basic principle you know very well. But the purpose is, with the help of Euler's method, okay, I can calculate what is called the position, the new position of the particle and the new velocity of the particle with respect to x direction and the y direction. Delta t means, okay, small change. This one, this I am referring this one. Okay, small change. Okay, 1 nanosecond. After 1 nanosecond, that is a delta change. Corresponding velocity, corresponding what is called force. So we can calculate position and the velocity. So in this reduction algorithm, we calculated force, okay, and this force value we are applying, okay, to calculate the velocity along with, okay, that is position also. So these are the general ideas about what is called the parallel programming concept. Mathematical model I demonstrated. With these mathematical models, okay, we can or this mathematical model we can implement on our OpenMP. OpenMP is a very comfortable model to demonstrate parallel. So you no need to write any program. The system itself will do, because the tool is functioning like this. Okay, with this idea, parallel how it is executing. So that is, you know very well, this is one location and this is a new location. This is the one velocity, okay, new velocity. This is the force and it is a new force. Everything. So for understanding purpose, only what is called two particles I am demonstrating. Millions of particles will move like this, and the system will record entire particles new position, new velocity and new force. Okay, how it is possible with the help of OpenMP. Okay, so please, my dear children, please understand, this is the basic concept. So with this idea, I would like to give you some MCQ questions. In this unit, I am not focusing much. Reason because everything is a mathematical model, so that I couldn't find that is more questions. Understand the pattern like this, okay, it will help you. Only 10 questions I identified. First question is the formula for calculating, okay, that is a force. Imagine that the particle should be in space, because according to that the formula. So already I explained to you, okay. So what is a formula? Okay, that is option 1, okay, that is option 2, then option 3. If required, I will reduce also to come to that is one line, okay. So it will come down like this, okay. So that is a 4 option. So this is the one, and this is the small changes. Please expect, okay, the questions like this, okay. As far as the first question is concerned, to calculate a force, okay, this is the correct formula, okay. So this is not a formula. What difference is there? Okay, here that is a cube and here that is a squared only. Small changes I myself made for understanding purpose. University exam also please expect like this. Okay, so that is the correct answer is this one. Okay, and the second question, what is the formula for calculating a total force? Okay, so that is a total force. Okay, here no, because a total force means 0 to n minus 1. Here only n is here, so that I didn't select this one. Option 2 also, okay, here that is m minus 1. So here also, okay, n is there. So this and all it is wrong. So please expect like this. They can give a small change with the formula, okay, to confuse you. So please remember, okay, and the formula properly, so that you can select the correct answer. Okay, so option 3 is the correct, because 0 to n minus 1, okay, 0 to n minus 1, and it is a calculation. And similarly, next one is, what is the formula for calculating distance between 2 points? Okay, distance between 2 points is, okay, this is the correct answer. I already shown this equation, okay, remember this equation, okay. And what is the formula for calculating acceleration of the particle in space? That's a very important one. Fourth question, okay, that is acceleration. Okay, this is the correct answer. Okay, why didn't select? Because here n only there. Okay, 0 to n minus 1 I wanted to consider, and like this. Okay, and you can refer that is the other things also. But as I already know the answer, I selected. Okay, please remember this equation. Okay, then after that, fifth question, reduced algorithm means. Why it is called reduced algorithm? Because I told you force Q, okay, in a column, and force K, column or row, okay, we can decide. Okay, so one of the forces we can take. That's the reason why considering upper and lower triangular data, no need. Okay, considering upper or lower triangle is correct. Okay, we can consider either upper or lower, depends upon our situations, depends upon the pattern, depends upon our programming. So 50% of the content no need to focus. Binary 1/2. Okay, that's the reason why, okay, searching tree, okay, it is divided by one branch it want to focus or no need to focus. That's the reason why it is called reduced algorithm. Okay, the answer is this one. Okay, similarly, sixth question, formula for calculating position of the particles. Okay, position of the particles. Okay, this is the formula. Okay, already I have shown you. Okay, so delta t is a small change. Because of this change, what is a new position in the x direction and the y direction? Okay, so sixth question, this is the correct answer. Okay. And the seventh question, formula for calculating velocity of the particles. Seventh question, okay, this is for positioning, and this is for acceleration. Okay, they may give different answer, and this is for velocity. Okay, so that is a velocity. Remember all the formula. Okay, then after that, eighth question, okay, very important question, n-body solver. Why n-body solver? To solve n-body problem. What is n-body problem? Tens of. I demonstrated that is 5 million particles movement. See, complicated task, process, but our system recorded. Reason because we have n-body solver. How n-body solver was implemented? with OpenMP. So that's a that is a strength of OpenMP. Okay, so 8th question, okay, that answer is first one. And then 9th question, serial n-body solver can be based on the following pseudocode. What are the things wanted to calculate for the solver? At a timestamp is very important. Timestamp means 10 o'clock, what's the position, what's the velocity. 10.1, what's like this. In each second, wanted record. That I am referring timestamp. Then computing position, computing velocity, computing total force and everything wanted to calculate. Here only position, no, wanted to calculate velocity and force also. Here timestamp is not there, timestamp is very important. So that's the reason why first is the correct answer. And then, okay, MPI altogether, okay, that is a MPI altogether is a very important what is called one tool in OpenMP, okay. So that the help is many to many communication pattern. That means tens of what is called particles, each particles will communicate each other. That's the reason why I am telling many to many communication. It is possible with the help of this tool. So this is the hard part of that OpenMP, okay, to demonstrate, to enjoy parallel executions. My dear children, with these words, okay, I would like to conclude. I would like to give that is a demo also, but it will take more time, so that I didn't explain everything. So that is, watch this video and understand the basic concept, understand what is called all formula. It will help you to approach and give correct answer in university examination. Okay, I thank you very much for watching this video. If you have any doubt, repeat this video, watch again and again to understand the concept very clearly, so it will help you. So if you are liking this video, I request you to like our channel and subscribe our channel also. And I would like to what is called help you for GATE preparation also. I will post, okay, that is a separate video for GATE preparation and some other guidelines. If time permits, okay, you watch that also. My dear children, all the best. Thank you.